Hi folks, my name is Simon Bennetts. I work for the Mozilla security team, and I'm the project lead for the OWASP attack proxy. Before I get started, I've got a couple of questions for you guys. First is there anyone here who hasn't heard about Zap before today? A small number. That's good, means the word's getting out. Is anyone here who uses Zap or has used Zap? A lot of you, most of you probably. That's really good. And just give me an idea of the makeup of the audience. Hand in the area developer. A few developers, great. QA. A few QA people, great. Pen testers. Fair number of pen testers, expected. Operations. And consultants, management. Oh, you don't have to be ashamed. There's a few of you around. That's great. OK, so what I want to do is I'm going to give an introduction to Zap, but I want to go through this fairly quickly because I want to get on the new stuff. So there are various other videos of other talks I've given and training videos, which you can find out more about Zap in detail, some more of the basics. But I don't want to focus on that too much because I'm pretty sure a lot of you know the basics already. So I'm just going to go straight in. And the first thing, obviously, what is Zap? So Zap is an easy-to-use tool for finding vulnerabilities in web applications. It is completely free and open source, and it's an OWASP flagship project. So there's only, I can't remember, 20-odd flagship projects. So these are the projects that are the most mature and the ones that OWASP really recommend you get started with first. So they're a really good introduction to application security. It is ideal for people new to application security. That's the aim behind it. That's what I wanted when I started. But it is also used a lot by professionals, probably more by professional pen testers than developers, to be honest. But I want to make sure that it's ideal for developers, particularly for automated security testing. I'm a big fan of automated security testing. I'll talk a little bit more about that later. But it really is becoming a framework for advanced testing, as I'll show later. And it's included in all the major security distributions. And I have to say, any of you who've been involved with application security for any length of time, you'll know there are no silver bullets. Zap definitely isn't it. It's part of how you can secure applications, but definitely not the be-all and end-all. So we do have some principles. I've mentioned free and open source. There is no pro version. There will never be a pro version. There are plenty of other tools out there that fill that niche. With Zap, we want to make sure that it is completely free and open source and will stay that way. And involvement is very actively encouraged. Any of you who've reached out to me will know that I try and drag you in. So I want people to get involved, and that's one of the reasons I say that it's never going to be commercialized. You know that anything you do will always remain free and open source. It's cross-platform. I kind of find it bizarre that people develop things for a specific platform these days. And we try and make sure that it's as easy to use and easy to install as possible. That's important for people new to application security, but it's good for the pros as well. You want a tool that works with you rather than against you. It is internationalized as well, which is unusual for a security tool. I think this is really important. Most of the world doesn't speak English, but most security tools seem to ignore that and English only, which I think is wrong. It is documented, and the documentation might not be brilliant, but it's there. So there's a lot of documentation there. We try and make sure we work as well as possible with other tools. And we use reuse as well. So rather than invent the wheel, if there's a good open source library out there, then we'll try and use that. Some statistics for you. So I released it just over 3 years ago, a fork of Paros, Paros Proxy. Some of you, I'm sure, have used. The last release was in September, 2.2.2. I don't know how many downloads we've had, but probably around 15,000. The last main release, 2.1.0, was downloaded 25,000 times. Obviously, that's not including all the people who've used Zap as part of all the big security distributions. It's been translated into over 20 languages, and we have over 50 translators at the moment. I'm really proud of that. I think that's very important. But I still think it's mostly used by professional pen testers, which I'm happy about, but I really do want to get it into the hands of more developers. And in case you think it's just a fork of Paros, I did some very finger-in-the-air stats recently, and I reckon about 20% of the code base is Paros code now, and 80% is new stuff. We're not trying to replace the Paros stuff. We're just doing new things and replacing Paros stuff where it doesn't work. It doesn't work the way we want it. There's a site called Olo, which I'm a big fan of because it gives me great stats, one of which is So it tracks loads, thousands and hundreds of thousands of open source projects. and it rates them based on activity, and Zap is in the highest category, so it's very high activity, so it's right up there with the Linux kernel and Firefox and things like that. And we actually have an OWASP project on Dolo with all the different tools, open source tools on there, and Zap is the most active OWASP project by some margin. We had 28 people contributed code last year to Zap, and they say they work out 236 years of effort. I'm a bit dubious about that figure. I reckon a lot of people contributed, but I've still done a fair proportion of that. I don't think I've spent 100 years on it, but I could be wrong. And you can see the number of commits per month. And all these things are on OLO on that URL, so that's a really good site for these kind of things. What we've on the Zap homepage, both on Google Code and the OWASP site, we actually have a user questionnaire. So we're trying to find out how people use it. So if you do use Zap, please go on there and answer the questions if you haven't already. And you can see things like, so vast majority of people think it's, well, everyone thinks it's very suitable or fairly suitable for people new to application security, and vast majority think it's very suitable for security professionals as well. There's loads more stats. So we've got all the questions there, but all the answers are there as well. And actually, the questionnaire has been translated into French and Spanish as well. Got a load of features, basically all the features you'd really expect. So it's intercepting proxy, it's got active and passive scanners, traditional and AJAX spiders. I'll talk a bit more about that later. WebSocket support. I'm not going to go through these in detail, and there's loads of additional features, but so if you want to learn more about these, the best thing is to have a look at the website, look at other presentations I've done, and play around with the tool, because that's the best way to learn. So I'm going to have a quick run through how you can use that, because that is one of the questions, and the people ask me, and it's a very good question. One way is point and shoot. So we've got a quick start tab, and you can just put in a URL and go attack. And what will happen is Zap will then run the spider against that URL and then run the active and passive scanners against that. That's very effective, but it's limited. If you've got authentication, then it's not going to be very successful. It's going to test your login page very effectively, and that's it. So that's, it's a great way just to get started. But it's more effective if you've got some authentication or a complex application, you're better off actually proxying your browser through Zap and exploring the site that way, because you're going to drive it in a more effective way. And then you can run the automated tools. For professional pen testers, however, they're going to start doing that, and then you're going to carry on, use all the manual tools, of which there are a lot. But another way that I'm really keen to get people to using Zap is automated security regression tests, and I'll talk a bit more about those in a minute. I've used it as a debugger. If you're actually doing web development and you've got some JavaScript libraries which are making requests, you don't know what's going on, just put Zap in there. You've got WebSockets or something like that. It's actually really good as a debugging tool. And if you find out you're doing something wrong, you can change things in line, essentially, rather than have to go and change the code. So you can say, what am I supposed to, I'll change that. Oh, that works. OK, right, great. And you can also use it as part of a large security program, because, as I said before, Zap is not the be-all and end-all. It's never going to be that. It can be very effective as part of a wider ecosystem of tools. I mentioned security regression tests. As a developer, I'm a big fan of regression tests. Regression tests are great. They tell you that you haven't really messed up. You don't ship just because the regression test passed. You go to QA and things. But you can have these running, so you can check code in and your regression tests run. And you have things like your build environment, so your tools like Maven and Ant controlling something like Selenium, driving a browser, driving application. And that's great. So a lot of people have that set up. But what we can do is we can change those into security regression tests. And that's pretty straightforward, relatively straightforward. What you do is, instead of driving the application directly from your browser, you put Zap in between. So that's a way of actually, another way for Zap to understand your application. And then what you can do is you actually invoke Zap directly. So we've got an API which covers all the main functionality. So you can actually kick off the spider to make sure you've got everything, then the active scanner, and then pull down the results. And if you've got any vulnerabilities in there, flag those. So you can just check code in and then get alerted as soon as you've made a change that you forgot to escape some parameter. And I've got more information there, and we're using this in Mozilla, and a lot of other companies are doing this, and so I really want to push this more. Also, I want to quickly mention about embedding Zap in a larger program. There are quite a few tools doing this. A couple I want to mention are ThreadFix from the Denim Group and Minion from Mozilla. They're similar tools. At the moment, I think Threadfix is more aimed at the security team, whereas Minion's more aimed directly at developers. But I think Threadfix are moving more towards developers as well. But both of these tools use tools like Zap and other tools. They drive those, and then they correlate the results and show trending and stuff like that. So these are really good ways of doing that, but there are other tools doing this as well. So what I want to say, Zap is changing a lot. We've added loads of changes. There's a lot going on. One of the reasons for that is Google Summer of Code. So we were part of Google Summer of Code last year. We had 3 projects. So Cosmin worked on the Spider. So traditional Spider, he completely rewrote it and put sessional awareness in there. So a lot of changes which we're building things on top of. Guifra implemented an Ajax Spider, which uses crawljack. So we're reusing software there, and that uses Selenium. So we can actually explore an Ajax-based application via this Ajax Spider, which is very powerful. And Robert implemented WebSocket support. And this is actually stunning stuff. So Zap has the best WebSocket support of any security tool, free, open source, commercial, bar none. So if you're doing any sort of WebSockets development or WebSockets testing, you should be using Zap. There's no other tool equivalent to it. At least nobody's told me that I'm wrong with that. So if you believe different, please let me know. But we were involved with Google Summer of Code this year as well. We had 5 projects, which is really great. So Cosmin came back again and worked on carrying on with his work on sessions. So he's actually so we actually can now understand authentication and users. And this is stuff that we're going to build on. It's not released yet, but it's into the trunk. And that's going to be very powerful. We're going to put some really fun stuff on top of that. Polasi implemented SAML 2.0 support. Prasad and Kevin mentored him for that. So, and that's available now for release now from the marketplace. We've got advanced reporting. So Ralph implemented advanced reporting, which was very needed because the Zap reports are not particularly good at the moment. And Joanna mentored him for that, which is really great. That's all checked in. We haven't packaged up as an add-on yet. We've just got a few tweaks to do for that. Abdeladi implemented a CMS scanner. So Islam mentored him for that, and so we can fingerprint CMS software. Again, that's all committed. We just haven't packaged up the add-on yet. Still a bit of work to do with that. And Alessandro worked on dynamic actions, which I'll talk a bit more about later because that's some of the stuff that I've been working on as well. And the code is committed, it's all included, but we're going to build on that more. There's a lot more to be done, but some really great work's gone into that. So what I've just talked about is the Google Summer of Code projects, but there's loads of other people working on other stuff within Zap. And one of the reasons I like the next couple of slides is because, well, the technology detection using Weaponizer, I implemented that, and I didn't do anything to any of the rest of the implementations on these 2 slides. So a lot of other people are getting involved. We've got an HTTPS info plugin add-on, so you can actually analyze the certificates, check for beast and crime vulnerabilities. We've got new or updated scan rules, so command injection, code injection, XPath injection, some new SQL injection rules, which actually use a port of the SQL map core, so very powerful there. And we actually support new targets, so you can attack headers, cookies, multi-part forms. And we now understand XML, JSON, GWT, OData. So we've actually got more support than a lot of commercial tools have, which is really great. And now's the scary part, for me anyway. So this is where I try and show stuff off. Now, I've told you about a lot of new stuff, and I'm not going to demo any of that. If you want to look at that, please have a play with it, download it. But I want to show you some other things. So I'm going to find Zap. And so this is Zap. And one of the things you'll see is we have this new plug and hack button. Now, plug and hack came out from discussions we had in the Mozilla security team. We kind of realized that security tools and browsers are actually a bit of a pain. So to get them to work properly, you've got to set up all the proxying, the certificates and all that. And it's a pain for security professionals. There's a real pain for people who are new to security. They often get that wrong, and it's very off-putting and stop them from using these things at all. So what we've got this plug and hack button, and that will just kick off your browser. Now, with Firefox, I've configured it to actually let me choose the user profile. Does everyone use profiles here in Firefox? Yeah, if you don't and you use Firefox, you really should, because what you can actually do, you can create new profiles, and they are completely new. So I'm going to create a new profile here. I'll call it AppSecUSA. And I'll start Firefox. And so we pointed at the URL, click to set up. And it's worked out that it hasn't got a particular Firefox add-on that it wants, so that's actually included with Zap, so it's nice and easy to install. So this is all fairly standard stuff. Then we've got a setup button, and we've got the scary warning. And this is very deliberate because you're setting up an intercepting proxy. You don't want to do this by accident. So I really do understand what I'm doing, and that's it. Right, so if I now go to a suitable test page, let's go into budget, then flip back to Zap, and we will see that we are now proxying via Zap. So you can see all the requests going through here. That's all very nice. As you see, it makes it nice and easy. But what we've realized is we actually needed a way to control plug and hack. And has anyone here heard of the developer toolbar in Firefox? If you haven't used that, again, it's really fun to use. So I'd recommend it. Shift F2. And what you can do is you can type help, and it will give you a load of lists. So this is built into Firefox. There's loads of fun things you can do. But what we want to do is we want P&H. So plug and hack is actually configured via this. You won't be able to see it properly. Just type P&H and you get a list of all the commands that are supported. So we can change the configuration, stop using Zap, whatever. But I don't want to do that. What I want to do is I want to type Zap. And now we actually have a set of commands that you can invoke from within your browser. So what can we do with that? Well, one thing we thought of was if you want to intercept something, you go to where you want to intercept, you switch across to Zap, you click on the relevant button, you switch back, you do something, you switch back, and there it is, it's intercepted. You can make whatever changes. That's all well and good, but it's a little bit clunky. So what we decided is what you can do is you navigate to where you want to go, you go to Zap, and you can set a breakpoint. So we want global, we want all, and we want it true. And then you click on something, and that's it. You can now switch to Zap, and it's sitting there waiting for you. As you can see, we're breaking on both requests and responses. We can unset those, and we can carry on. So that's nice. It means you're not switching between your browser and your proxy. We can do some other fun things. So let's go and do Zap. And I'm going to create a new HTTP session, and I'm going to call it Fred. You won't actually see any difference, but I'm going to have to register. So let's have Fred at Fred. So I'm now logged in as Fred, but I don't want to be. So I'm going to go and create a new session called Jim. And I'll go back to Zap, and you see I'm no longer logged in, top right-hand corner, guest user. OK, so let's go and register Jim. So I'll have Jim at Jim. And so I'm now logged in as Jim. And you can do some stuff as Jim, and then you can go back in here and type Zap. And we're going to switch session on localhost, and I want to go to Fred. And now I'm logged in as Fred. So from your browser, you can actually switch between HTTP sessions. And you can do all that in Zap. So go back here, and we have an HTTP sessions. And if I select the right site, you can see that down here, those you can't see it, it's got Jim, Fred, and we can switch between those in Zap as well. But it's so much easier to do that all within your browser. So you can do some access control testing. You can log in as an administrator, get to a particular form, then switch to an ordinary user and submit that form. So we think this is really powerful, and we think there's going to be loads more we can do with that. Right, so that's plug and hack, phase one. And what that does is allows browsers and security tools to integrate more easily. And it also allows security tools to expose functionality to browsers. So Zap was telling Firefox exactly what it could do and the endpoints. There's nothing that's built in there. That's all just metadata from Zap. But now we could say we just want this to be part of Zap and part of Firefox. We didn't. We want this to be adopted by as many other tools as possible and browsers. So there's a proposed standard. We've developed it, but we want other tools and browsers to support it because we think that would be good for the industry. So obviously we've got Firefox and Zap signed up. Another tool we produced called Minion signed up. But Burp Suite's also implemented it, also WTF, Kali. So people are starting to implement this stuff, which is really great. So the next thing I want to talk about is scripting. So Zap has had a scripting console for quite some time, and that allowed you to run scripts in place. You could write a script and run it. It would have access to all these Zap internals, but it was kind of, it only ran when you told it to. What we've done now is we've actually embedded scripting within Zap. So we have standalone scripts. You say when to run them. We have targeted scripts, so you actually specify what URLs they run against. And you can actually create active and passive scanning rules using scripts, and we can have scripts that run in line as part of the proxy. So I'm going to switch back and have a look at the. So we've got this new scripts tab. And as you can see, we've got the scripts here. We actually have a load of templates as well. So have a look and find a targeted template for finding comments. So I will make that into a new script. So we have this targeted script, and you can see it all here. And so targeted means you go to the sites tree, and you can right-click on one of these things, and we've got invoke with script, find HTML comments. We can run that, and then that script runs. So you can pass any URL to one of these targeted scripts to do whatever you want. Also mention that you can have active and passive rules. So we want to create an active rule. So we'll call it AA. And so an active rule, and this time I'm going to use Python. So we actually have inbuilt support for JavaScript, but we've got Ruby and Python are available, which have templates associated with. You can actually use any JSR 223 language, but you then won't have the templates. You have to work out the structure for you. But I'll just create that. So the templates, you can see one of the templates here. You might not be able to read that very well, but you can try this stuff out. And what this does, it actually sets up a very simple rule, and it will always raise an alert. So I'm going to enable that, and then go to the history panel and find something suitable to run it on. Right-click, attack a single URL. We go through fairly quickly, and you actually see there that because we've got a message somewhere in here, a debugging message. So you see that happened, and you can see down here we have an active vulnerability has been raised, passing all the data. So you can very quickly create active and passive scanning rules, which we think is very powerful. I'll just disable that. But one of the problems we decided was scripts are great. They're very powerful. But in a way, they're still quite complex. You have the UI on one side, so the Zap UI, just point and click, but that's restricted. Then the other extreme, you can actually do whatever you want. You can download a development environment, you can reprogram, you can put new Java in there, you can change it, you can do whatever you like because it's open source. But you're not going to do that in the middle of a pen test, are you? However, you've then got the scripts, and so they have access to as much of the Zap internals as possible. And if there's anything you can't access and want to be able to, then please let us know. But you still have to understand the Zap internals, and you have to be able to program in those languages. And I had this bizarre idea that was actually something in between, something which should be easy to use, but still very powerful. So we did something really stupid, bizarre, and that's to create a new scripting language. Because it seemed like and I've never done it before, so hey, it's fun. So this is a new scripting language, and it's really, and it's called Zest. So it is an experimental scripting language. It's very new. It's being developed by Mozilla security team, but everyone's welcome to join in. It is free and open source, of course. And the format's in JSON. I will show you. It looks horrible. But the idea is it's actually tool independent. It's designed to be consumed and used by other tools. And we actually want people to use it. So it's licensed so that anyone can use it, whether open, closed, free, or commercial. And we include it in Zap. And we got some, and this is one of the things that Alessandro was working on with me. And we got some use cases, one of which is reporting vulnerabilities to companies. So at Mozilla, we have a bug bounty, both on Firefox and on various websites. We get a kind of a variety of bug reports come in. Some are very good, some are not. Some are awful. So what we want to do is make it easy for people to submit vulnerabilities, make it clear what went wrong. Also, reporting vulnerabilities to developers. As pen testers, how do you communicate vulnerabilities to developers? You use PDFs, you use emails, you use bug tracking systems, and you use terms and tools that developers can't use and don't understand. These are not effective ways of communicating. What you want to be able to do is supply a script which easily reproduces that problem, and the developers can then use to test their solution. And also, we want deep integration with security tools, I'll also show. So let's start off by, what I want to do is reproduce a vulnerability in the budget store. So, and I'm going to use plug and hack to kick this off. So one of the options we have is to record on. So I'm now going to go to the Contact Us page, and I can never remember this, so I will copy and paste this. Here we have our vulnerability. And just to tidy things up, I'm going to go Zap record off. So what does that give us? Here is a Zest script on this side. It's horrible. You don't want to write that. However, what we have is over this side, if you can see it properly, that's a graphical representation of the Zest script. That's how you're supposed to use it. You can't actually edit this stuff on the right. We don't want you to. You don't want to go there. And what we can do is we can run this script. And if you can see down here, we see the results, and we see it's failed, which is a bit bizarre. I mean, what does a failure mean in this context? Well, one of the things, so what Zest does, it makes request responses. How do you know a request has worked or not? What we decided to do is we have this concept of assertions. Now, Zest doesn't say whether you have to use them or how you have to use them, but what we've done in Zap, we've decided to double-click anywhere on Zest scripts to see more information. So we have some default assertions. You can change those if you want. One of those is checking the status code, and the other one is checking the length, an approximate check on it. And you might not be able to see, but down here it's failed because we've got a 1.6% difference, and we said a maximum of 1% difference. So I'm going to right-click and compare with the original response. So we can actually see, right, the original, we were logged in as Fred, and because Zest runs scripts in a new context, we don't pick up anything from the browser or the tool, we're not logged in as Fred. So that's why we've got a difference. Okay, so we can actually go in and change that to plus or minus 2. And you want to change this one to plus or minus 2. And we can run it, and it works, which is fine, what you'd expect. But some strange things are going on. If we have a look at this post request, we'll see it's actually got an anti-CSRF token. But it still worked. And the reason it worked is because we have an assignment here. Now, this isn't, so Zest does not understand about CSRF tokens or anything like that, but Zap does. So Zap detected you've got an anti-CSRF token in, and because one of those tokens was returned by the GET request, we automatically assigned a variable to it, and we assigned it via form 0 and the anti-CSRF field. So I can actually change that to the user. And if I rerun that, it'll then fail because we're not using the right token. So I'll double click on that and change it back to that. And that will now work. Because what happened is when we actually made the post request, Zap detected that one of the previously generated tokens was being used, and we actually replaced that token with the variable that was set up before. So this actually makes it very easy. And what you can do is you can record Zest scripts. You can also go to the history and just say, right-click on something, add that to a Zest script. So we've got this deep integration with the tool. And Zap can do things that make things very easy for you like that. So somebody could actually then save that script. We've got an option to save to disk, or cut and paste this, and they can send that in to whichever company, and then the company can reproduce that easily. And what you can actually do is we have options. So you can actually change the prefix. So I can change it to use a staging site instead of the live site. We can put parameters in. So you can actually have parameters set up. So if you actually got to log in as a user, you can put the username and password in as parameters to make it easy for people to change. We handle basic authentication. So we handle quite a lot of things. And obviously, form-based authentication, you can handle exactly this, via this and put parameters in. So this is very powerful. It's a great way of reporting vulnerabilities. Say we want to hand this over to developers. Well, we don't want a script that passes. That's not what it does. So we want to go to, let's have a look at these results and have a look at the response. And somewhere down here, we will see the alert. So I'm going to highlight that alert, right-click it, and I'm going to add a condition, a regex condition, and you select the variable name, so it's the response body. And we then get this if-then-else structure. So if we see that, then we want to fail. So we've got a fail action. So we can say XSS. And if I now run this script, you'll see it now fails with the XSS failure. And we actually raise an alert as well. So we've got the XSS alert, and any information I've added to the script will be passed in there as well. So you've actually got something you can hand over to a developer. And we're hoping other tools will support this as well. So you can actually have the security team using a very different tool, using the security tools, and then hand this over to developers, and developers can use their own tools or Zap or run it from the command line. So we think that's the direction we really want to go, and we think that's really powerful. So when preparing for these sort of talks, it's always difficult to know what to demo. So I was really pleased when I got this tweet a couple of days ago saying, does Burp or Zap check for a response body after finding a 301.2 in headers? Shouldn't be content, but occasionally is. And I replied, I don't think we do have that, but it should be easy to create a Zest script to do it. OK, time to put my money where my mouth is. So what do we want? We want it's passive. It's going to be a passive rule because we just have to look. We don't have to touch anything. So 301, 302 with body. So passive rule, and we want to use Zest. And we've got a template there. So here we go. And so all we get is we got a comment and a print action, so we can see it's been called. So what do we want? We want a conditional, and we want to check the status code. So we want a 301. Actually, no, we want 301 or 302. So right-click on that. Right-click everywhere in Zest and Zap as well. So we can surround that with an OR expression. And then we want to add a expression of another status code of a 302. Now, I could carry on doing this all with expressions, but I want to make it a bit cleaner. So we know it's a 301, 302, so into the then clause, have another condition, and this time I want to check the length. And we can choose, so response body, length 0 plus or minus 0, that's good. So if the length is 0, it's fine, else we're going to add an action, and the action is fail. And we can put in that stuff there, and we're going to call it a medium. And then we're going to enable this script, because by default scripts aren't enabled when you start editing them, because otherwise things could go crazy. And that's it. So let's go back to my test links. So I've got a 302 with no body and a 302 with a body. We go back to Zap, look in the history, scroll down. Hopefully we'll see we've got the 302 without a body, and a 302 with a body. And we now have a look at the alerts. If I can find them, we should see we have a blah, blah, blah alert just on the body and not on the one with no body. So I've created that script in, well, I didn't time it, was it 60 seconds, a couple of minutes? And I was doing that on stage, talking you through it. So I think that's kind of powerful. Let's have another look at the kind of things we can do. So got another link here. And anything will be reflected. Yeah, appears to be okay. Let's go for our usual script. And it wasn't reflected, which is strange. So let's go and have a look in the history. Scroll down to the bottom, and we can see the post and look at the response. It's there, but we have a content security policy. Okay, well, that's fair enough. I mean, so that's reasonable. But one thing you notice is we've actually got another request here for the CSP report. Okay, so we're going to, every time we hit this application, we're going to get something that's going to get logged, which can be a bit of a pain. So let's see if we can do something about that. So it's CSP report. So this time what we want a new script, and we want no report. So this time it's going to be a proxy rule, keep it as zest, and we want the template. So this time, so with proxy ones, they get called twice. They get called once for responses, one request, once for responses, but this template actually shows you. Now, we're not going to get a request for one of these reports because they're generated from the browser. So we're in the response path. So I'm now going to put a condition in, and I want a URL condition. So we want CSP report.star. And so if we hit that, then what we want to do, there's a comment here that tells us set the request header to an empty string to drop the response. So we're going to assign variable to a string. So we want the request header set to nothing. Okay, and we want to enable that script. Let's go back here and reload that and then try our script. And we'll see now that we had just the post, but we didn't have the report generated. So I found a URL I didn't want the browser to visit, and I put a rule in very quickly. Which is okay, but I mean, say you want to test this application in a bit more depth to see, what bad stuff you can do. Obviously, this CSP content security policy is going to get in the way a bit. So what can we do about that? So we've got the content security policy. I'll copy that. And I will disable that script. I will create a new script, and I'm going to call it no CSP. Save that. And what we want to do is on the response, I'm just going to do a blanket replace. So a zest assignment and replace in variable. So we want the response header. We want to replace the CSP line, everything on there, with content security policy. So regex, save that, and enable that script. And then I'm going to regenerate and refresh that, try my attack, and there it is. So we've disabled CSP, obviously in the browser, via Zap. But you can see how quickly you can do these things. And you can do all these things with scripts, but then you have to know the syntax, and you have to know the internal data structures to do these things. With Zest, if you do it via this interface, there are no such things as syntax errors. You can't create a Zest script, unless you made a mistake somewhere, that will actually allow you to do anything wrong. And everything you can do is enabled via right-click options. It shows you everything that's possible. And if you want to, whenever you see something, you can actually right-click in there. And let's find most of these things, obviously not that one. you can actually paste all the variables in. So it'll actually show you what variables are, and you can paste them in wherever you like. So, quick question. You've just seen me demonstrate Zest. How many people in here think they could actually create a Zest script with a bit of playing around? Most of you? Anyone think they couldn't do that? Better question. Nobody's saying they couldn't do it. No, the peer pressure. That's great. OK. So, demonstrated plug and hack phase 1 and Zest. And so Zest has a load of different statements. It's got requests, assertions, conditionals. We've got loops, so we can actually loop around fuzzing files and attack things. So we can actually attack a wizard with loads of different forms, all with CSRF tokens in, and actually just fuzz one of the fields at the end. You can do all those sort of fun things. So you need a Zest runtime, because it's defined in JSON. We've got a Java runtime, so that's the reference implementation that Zap uses, but it's completely independent of Zap. Anyone can reuse that. I'm actually looking to develop JavaScript and Python runtimes as well. So if you want to help out with that, please get in touch. So the last thing I want to demo is some work that isn't quite finished yet. We're still working on it, but it's plug and hack phase 2. So plug and hack phase 1 allowed you to actually expose the tool from the functionality of the security tool into the browser. Plug and hack phase 2 allows the tool to delve into the browser. And with this one, we don't actually need browser plugins. Now, this work, so we haven't actually released this yet, but it's all committed. So if you want to, actually go and check it out. Literally check it out of SVN and try it out if you want. So I'm going to go to another little test page. So we have this page. Uses post messages, and this is actually code I ripped off from the internet. I just did a standard Google search, found the first decent example I could, ripped that code off, and here it is. As you can see, you post messages from one frame to another. And we can go into Zap, and we can see that the page has been requested, but you can't actually see the post message. And that's because post messages stay on the client side, which is a pain if you're a penetration tester and you come across this stuff. So what we now have, if I go to the Sites tab, there is a new menu. If you right-click, we have an option to monitor clients. And I'm going to monitor everything in a subtree. And what you'll actually see now is you get a different icon on that subtree, all well and good. And if we reload that page, we will see that actually some of those will have changed color, which isn't really that impressive. What is slightly more impressive is if you go to, there's a Clients tab, and actually shows you a couple of tabs down here. So it shows you a couple of URLs and got a little Firefox logo. So if I should go back to here and click on one of the budget store links, because that's in the same subtree, we'll see we actually see that tab as well. If I go back and close that, then after a few seconds, that one will actually disappear. So somehow Zap is monitoring which tabs and windows are open in the browser, which is interesting. What's more interesting is if we actually click on this button, then you will see the message down here. So you can now see post messages. That's all you want to do, isn't it? No? Obviously not. You can intercept and you can change HTTP messages. You can intercept and change HTTPS messages. You can intercept and change WebSocket messages. What you really want to do is you want to just treat post messages as anything else. So you want to set a breakpoint, post your message, and then have it in there in Zap, where you can change it to be whatever you want before sending it on to the browser. That's what you want to do, isn't it? Actually, what you really want to do is you want to have your message, you want to double click on it, you want to highlight it, and you want to fuzz it. And then you want to go down, I don't know, select some XSS rules, a couple of those, and you want to fuzz that. And so what we're now doing is we're actually fuzzing post messages in the client being controlled by Zap. And we'll wait a couple of seconds. I have a sneaking suspicion, if the demo gods are good, that we have an XSS, a DOM XSS vulnerability. The DOM XSS vulnerability is a post message which we found from fuzzing via Zap. So we've actually got a security vulnerability in widely used example code on the internet. Who would have thought that? What, all of you? You cynics. Actually, it could be a little bit better, because what we could do is we could right-click that, fuzz it. Instead of using one of those rules, wouldn't it be nice if we had a custom fuzz rule where we actually did something even better, and rather than get the pop-up, what we actually got was alerts kind of in Zap, which told us that we'd hit a DOM XSS oracle in the client. So we know these tests actually really did hit that vulnerability, and we haven't got a pop-up that we've got to cancel or whatever. So how does that work? So what we're actually doing is we are injecting JavaScript into the monitored pages. That's why it's a separate, that's why we don't do it for everything, because you're actually changing the responses. So we're actually injecting JavaScript, and it's very clever JavaScript. I can say that with certainty because I didn't write it. One of my colleagues, Mark Goodwin, wrote it, really neat stuff. And this is actually, we're trying to make this as browser independent as possible. So this works in Chrome. We're going to try and make sure it works in all the other browsers as well. So we don't actually need browser plugins. And what we then get, we get a heartbeat from these pages. So that JavaScript gives a heartbeat, so we see what's actually alive. And because of that, we can then intercept messages, and we can send messages back. So we can intercept and change post messages. And as you saw, we can fuzz post messages. And we've got a DOM XS oracle in there as well. Now, this really is only the start. As you can imagine, there's quite a lot of the other stuff on the client that we want to get hold of and do things with. And that's what we're going to do. But what we really want is, again, we could have made this just Firefox and Zap specific. We didn't want to do this. This is all open source, and this is being packaged up as Plugin Hack Phase 2 so that other tools can use it as easily as possible, because we want it to do good for the industry. So that is the end of my demos. I do want to tell you that there's a Zap hackathon tomorrow, so from 9 to 1, and that we'll actually have a chance to delve right into the depths of Zap. So you can actually find out how to do some really nasty things and actually extend Zap to do whatever you want. So I'll cover the coding, scripts, localization, documentation. So if you want to contribute to Zap, that'd be great. It'd be really great to see you there. And my plan is to do demos and then give you time to work on stuff, but I'll be around to answer any questions. One thing I want to mention is we've got a load of Zap T-shirts in the merchandising thing. What a lot of people don't realize is in your welcome pack, you actually have some blue tokens. You exchange those for OWASP goods, so you can get these for free. Essentially, just hand over 4 of your tokens to get one of these T-shirts. So in conclusion, I want to just make sure you realize that Zap is changing very rapidly. There's loads of stuff going on there. We're introducing new features that actually exceed the capabilities in any other tool, free, open source, commercial. But we're actually trying to implement a load of functionality that actually can be reused in other tools. We want the other tools to get better. We believe in a free and open web. We want to try and make all tools and products as secure as possible. And Zap is a real community-based tool. I really want people to get involved, so please get involved and talk to me if you want to get involved. We also want feedback from our users, so if you do use Zap and you haven't filled in the questionnaire, do that, and please come along to the hackathon tomorrow. So, who's got the first question? So I will repeat that question to make sure everyone can hear it and they hear it on the recording. Is the Zest scripting in Zap? Yes, it is in there right now. So everything I demoed is in there apart from the post-message stuff I was playing around with at the end. All the rest is there. The post-message stuff is also checked in. You just have to build and redeploy the plugin hack add-on. But all the scripting there's there right now.
So if I find a vulnerability using Zap, how would I use Zest exactly to report that vulnerability to a third party?
Well, what we're going to say for Mozilla is we would actually like you, and this will be our policy when I get around to writing it, that we'd actually the preferred way of reporting a vulnerability on a Mozilla website will be to supply a Zest script. So you'll actually be able to, you can either email it to us or raise a bug, but just give us that script. Because what we can see what you did and what the responses were. One thing I didn't show you can actually redact stuff, so you can highlight. So if you've got username and password in there, you can actually just highlight the password, redact it, and then we don't get any of that. Obviously, you can go and do it manually as well. But we actually see exactly what happened, which is really useful for us. Even if it's hard to reproduce, we see exactly what was going on. But it's easy for us to then point at a staging site. And Zest scripts, I think are very easy to read. We haven't had anyone doing a ridiculously complex one yet, but you know, for this simple stuff, it's pretty straightforward to see what's going on. I do. I'll give you 3 guesses. The documentation for Zest is lagging behind. My boss has been trying to get me to do documentation for a while. It's on my list of things to do. I'm going to record a demo, a 10-minute demo or something, showing as many of the Zest features as possible, but I need to document it better. So there is some help files, but it's not great, sorry. It should be so intuitive, you don't need documentation, but I know you do need documentation, so I just hate doing documentation.
Does Zest have the ability to call other Zest scripts?
It has the ability to call any script. So we can call Zest scripts, we can also call Python, Ruby, anything else. And then if they return anything as a response, you can assign that to a Zest variable and use it. So you've got crypto or anything, you can call that to Python. So you do not want to do, you'll never be able to do crypto with Zest. That's not the idea behind it, but you'll be able to get that stuff back into using any other programming language. Okay. Thank you very much, folks.
Thank you.